of the warm-up together. Number 1. What is the first thing you guys did? Good. Add 10 on both sides. So then you have 2x to the 4th equals 32. Remember, the whole point right now is you're trying to get x to the 4th all by itself. Divide both sides by 2, so you can get rid of that.
X 4 equals 16, and then x equals 4.
Alright, so you have x to the 4th equals 16. Now what? Good. You gotta take the 4th root. Yeah. Well, the 4th root, what does the 4th root need?
Plus minus.
Plus or minus, because that is an even root. So then, x equals plus or minus
2.
2. Good. And like I said, with these power equations, you know, you're checking to make sure that your answer is right, because they'll always work, right? All right, let's look at number 2. Okay, so number 2 looks a little bit different because you have parentheses and an exponent, right? So you want to get this all by itself. All right, so subtract the 2. And then you have x minus 4 cubed equals 8. Yes? Now, how do I get rid of the power 3?
The root.
Take the root. Good. But you got to take the root of 3. So cube root, right? Now tell me, does the cube root need a plus or minus? No. Why? Good, because it's an odd root. Good. Good job. All right, so then you have x minus 4 equals, what's the cube root of 8? 2. Thank you, Cindy. And then now we can just solve. Add the 4. So x equals 6 for this guy. Yes?
Yep.
All right. Questions? Okay, good. Okay, so today we're going to talk about solving root equations, okay? So just to kind of, you know, prepare you guys for what we're doing, last class we solved power equations, right? So last class we went from this, x cubed. How do you get rid of a cube or the power? How do you get rid of that power? You take the root. So since this is a power of 3, we took the root of 3, right? The cube root. And then we got x. Yeah? That's what we did last time. We went from the power and we took the root to get rid of that power. So today, what we're doing is we're going to take the root, right? We're starting with the root. How do I get rid of a root then? Well, if I have the power, and to get rid of the power, I took the root, then if I give you the root, how do you get rid of the root? You take it to the power, right? Basically, we're just going the other way this time. Since that's a square root, I take the square. Okay? So last time I went from exponent and I had to take the root. This time, we're starting from the root and I got to take the exponent. That's what we're doing, okay? Just backwards. All right, so up at the top, let's look at our first example. It says the square root of y minus 2 minus 1 equals negative 5. All right, so the first thing you want to do is you need to isolate your radical. It means get just your radical or your rational exponent all by itself. All right, so in order to do that, I need to add the 1. So that's what I have. Square root of y minus 2 equals negative 4, right? Now, the next step says change any exponents to a radical. Okay. Do I have any exponents here? No, so just skip that. An A. Now, let's bring down our problem, right? We have square root of y minus 2 equals -4. It says, step 3 says, raise each side to the power, because we need to get rid of the root. Since this is a square root, what power do I have to take?
2.
2. And whatever you do to one side, you do to the other side. Okay? So then that square root and that square cancel out. Then I have y minus 2 equals, what's -4 squared? -4, make sure you put that in parentheses. Good. 16. Yes? And then the next step says solve for the variable. How do I solve for y?
Add 2.
Add the 2. So y equals 18. Now, it says check your answers. And you know what, guys? I'm going to show you something that I think is very, very helpful. I just need you to pay attention to this, okay? It's in your calculator. We're going to check our answers, but we're going to use this method that's a store method, okay? What is my answer here? Y equals what? 18. So 18, we're going to tell the calculator to store it for x, okay? So let me go to my calculator. All right, so here's what we do. In your calculators, let's press 18, and we're going to store. You see the store button is right above the on. Store it for x, and hit enter. Your calculator told you 18, right? Okay, so this is what you did. You just told the calculator, anytime I put in an x on this main screen, the calculator needs to plug in 18, okay? So now, let's go and find our original problem, and let's just put that in. Square root, I know it says y, but in the calculator it's always x. Minus 2. Oh, and your radical ends there, so either close your parentheses or arrow out, okay? And then minus 1. Do you see what I'm doing? Now, when I hit enter, my original problem says this should equal -5, doesn't it? Does it equal -5? No? You got 3? All right. We did everything right, but when we plugged it in, it didn't work, right? So, what I need to do is, I'm going to go here, I'm going to put an X. I'm going to say, no, it didn't work. Okay? So really, this is my solution. It's no solution. Even though I did the math correctly, when I went back to plug it in, it did not work. When you solve these root equations, sometimes that happens, so you must check, okay? So when you look down at the bottom, it says a blank solution is when your math is correct, but the answer does not work in the equation. These solutions are called extraneous. Okay? An extraneous solution is when your math is correct, but the answer does not work in the equation. Okay? Questions? All right, let's try the next one.
Will you do any rows on the top?
On the quiz, yeah.
Extraneous solution.
Yeah. All right, so let's try the next example. So this one, it says, isolate the radical or the rational exponent. So the rational exponent means you have a fraction as your exponent, right? So when I look at this, oh my goodness, I do have a fraction exponent. It's right on that x, right there, right? That is what you want to get all by itself. So I'm going to add the 5 first. What is 19 plus 5? 24. And remember, I'm still trying to get this x to the 1/3 all by itself. So what do I need to do?
With it.
Huh? Not yet. Get rid of this 4. How do you get rid of that 4?
Or subtract it. Divide.
Divide it. Since they're multiplying right there, you undo multiplication by division, right?
Yeah.
And then we have x to the 1/3 equals 6. Now, my next step says change any exponents to a radical. So here, this is power over root. Remember this, guys? We did this in Unit 5, right? So we're taking this and we're going to turn it into a radical. So draw my radical. What goes inside there?
X, 1/3.
The x. What's the root? What number goes at 3? And the power is 1. Do I have to write the 1? No. Equals 6. There you go. We rewrote it. Not bad, right? So now we're going to solve it the same way that we solved the last one. We're going to get rid of that root. Well, how do I get rid of this cube root?
3.
Good. Take it to the power. Okay? Power of 3. And whatever you do to one side, you do to the other side. Okay? So then now that cube root and that cube, they cancel each other out, and you have x equals, oh, what's 6 cubed? Good. So x equals 216. Okay? Now, last step, we need a check, and we always need a check, okay? So I'm going to use my store function again. 216, store for x. Store or stow for x. How it looks on the button. So I'm going to go back to my calculator, and everyone should try this, okay? Make sure you know how to do this. This is a really handy tool. 216, stow x. Hit enter, and you get 216. Now, go and put in your original equation. 4x to the, what do you need to do with this fraction exponent? Parentheses, thank you. Parentheses, 1/3. And then, minus 5. When I hit enter, you get 19? Yes. So is this a solution? Yes. Okay. Look at what I put in the calculator and look at what you have, okay?
Graph minus 5.
All right.
Yeah, I got it.
Good. want you guys to be, you know, just actively aware of what you are putting in, okay? You can totally do this. I mean, there's no reason why you should get these wrong when you're just plugging it in, right? So make sure you put a little check or yes, something, okay, that shows me that you checked this. Questions? All right. Can I pick up the pace a little bit? All right, let's try number one. So, number one, remember, you're trying to get either the radical or your rational exponent all by itself. So this guy, square root of 2x minus 3, that's what I want to get all by itself. How do you do that? Is it multiplying? Subtract 3. Be careful, because this is 3 plus, so you need to subtract the 3. So then we have the square root of 2x minus 3 equals 5. Now, guys, how do I get rid of the square root? How do you get rid of the root? Take it to the power. But what power? 3, 5, 2. Okay? You get rid of the root by taking the power. And whatever you do to one side, you do to the other side. Are you writing this down? Write this down. 2x minus 3 equals, what's 5 squared? 25. And then look, perfect. That's a nice, pretty, linear equation that we can solve, right? Solve for x. Divide by 2. So what is x? What did you get? Thank you, 14. So now let's check. I'm going to put 14, store it for x. Right? So everyone should practice putting this into the calculator so we can check. Put this in the calculator. All right, when you hit enter, did you get 8? You got decimal? Okay. Sabrina, check what you put in the calculator compared to what I put in.
So it's less.
No? Okay. Okay, so this one works. Make sure you put a check, yes, something, okay? Show me that you checked it. All right, so number 2. So number 2, I really like these problems because, I mean, you're going to see them, and I think they're a lot easier. Looks crazy, though. Whenever you have 2 roots, 2 radicals like this, okay? Make sure you put 1 on each side of the equal sign, right? Don't let them be on the same side. So what I'm going to do is I'm basically going to take this minus the root, and I'm going to add it so I can move it to the other side. Okay? It's like if that was a minus x. How would I move it? I would add the x, right? It's the same principle here. Alright? So then that goes away, and then we have square root of x plus 15 equals the square root of 3x plus 1. Questions about that? You're not writing this down? All right, so now just look on one side. You have a root. How do you get rid of the root? Take it to the power. What power? 2. Whatever you do to one side, you do to the other side. Oh, so isn't this nice? What happens to that square root and the square?
Cancel.
Yeah. So on the left side, gone. How about on the right side? What happens to the square root and that square? Gone. Right? So then basically what you have left is what was inside. X plus 15 equals 3x plus 1. Okay? And then now we can solve. This is just a multi-step.
You subtract the x.
Sure, let's do that. Then 15 equals 2x plus 1. Now what?
Minus the 1.
Good. Minus the 1. 14 equals 2x. And then divide by 2. So x equals 7. Now let's check this. 7 store for x. Right? Now when I put this in, I'm going to do 7 store for x. Don't forget to put that in. You got to tell the calculator what number to use. Now my original problem, let's see. Be careful because you have 2 square roots here. Square root of x plus 15. I'm going to close my parentheses because that first one closes there after the 15, right? Or you have to arrow out. And then minus square root of 3x plus 1. And then close again. When I hit enter, you got 0? You got 0? So is this a solution? Huh? Look at your problem.
Yeah, it's a solution.
Yeah, it's a solution. All right. So this is a solution. We checked it, so I'm going to put yes, it works. Huh? Oh, good. Too late. All right. Let's look at this, guys. What do I want to get all by itself? Not the 3. Just that square root of x. Just get this all by itself. Now I want you guys to try this. You can do this. Alright, I know you guys are still working. I'm going to start putting my work up. Some of you guys are done. Maybe you added the 1 first. Good. What do you do next?
Divide 3.
Good. How do you get rid of the square root? Good. You have to square it. Take it to the power of 2. Whatever you do to one side, you have to do to the other side, right? So then that goes away. Then you have x equals, what's negative 3 squared? 9. All right, so they say x equals 9. Let's check. So by checking, I'm going to take 9 and store it for x. Because you got to put the negative 3 in parentheses. All right, take the 9, store it for x. Did it work? All right, Kevin's saying no, it didn't work. Anyone else? I see Timlin working.
Can't put it in. I got
Why? What'd you get?
8.
You got 8?
Yeah.
I mean, if you put it in right and it's not giving you the answer, then maybe it's not a solution. Let's see.
Would you like close parentheses after x?
Yeah.
Okay.
Mm-hmm. Close your parentheses after the x because that's where your radical ends.
And it's extraneous.
Yep. Yep, good. It did not give you negative 10. It gave you 8. That means that this one is extraneous. So this is no solutions, right? Because we only had that one. If the one that we had didn't work, we don't have any solutions for this. Good. Let's look at the next one. So I have 2 roots. Again, what should I do? Add. Add this one over. Because when you have 2 roots, you can't have both of them on the same side. One has to be on the left, the other one has to be on the right of the equal sign, okay? So a minus and a plus, and that goes away. Then we have cube root 6x plus 9 equals cube root of 3. How do you get rid of the root? Take it to the power. What power here? 2? 3. It's got to match this root, okay? 3. Whatever you do to one side, you do to the other side. What happens to the root and the cube? Are you writing this down? Focus, focus. They go away. And on the right side too, they go away. So you have 6x plus 9 equals 3. Well then, you know how to solve this. So I got x equals negative 1. Can you check that? Negative 1, store it for x. And remember, a cube root is under math. Math 4, right? Remember to use cube root. Is it minus 9?
Why don't they teach us some of this stuff in like algebra 1?
Because if you mess it up, then it's just too much. In algebra 1, it's not as complicated, so you could just plug in the x. You know what I mean? And you have to understand that concept. You're plugging in. Yeah? By the time you get to algebra 2, I figure you know that when I say check, you're plugging that number back in for the x, right?
0. Yes.
Good. So is that right? Does it match your original?
Yeah.
Yup. So it is a solution. This is a yes. Good. Alright. On to the next one then. Yes. So fun. Now we're on to the rational exponents, right? Ethan, so fun. Alright. So get your rational exponent all by itself. The thing that's with the rational exponent. So since you have a parentheses with that fraction exponent, you got to get all of this by itself. Okay? How do you move that 8?
Divide it.
Divide it. Good. Whatever you do on one side, you do to the other side.
Negative 6.
All right. So you have x plus 1 to the 1/4 power equals negative 6. So remember when you have a fraction or a rational exponent like this, we said to rewrite it as a radical, right? So this is power over root. So I'm going to write my root. Since the x plus 1 is in parentheses, that means all of that goes in there. What's the power on that? 1. So I'm not going to write the 1. What's the root? 4. equals negative 6. So now, back to the normal business, right? How do you get rid of this fourth root? Take it to the power. Power what? Power 4. And whatever you do to one side, you do to the other side. Please notice how I'm putting parentheses around the stuff on the other side. We're going to take it to the power, okay? So then those go away. And then I have x plus 1 equals, what is negative 6 to the 4th power? $1,296. Good. Now how do I solve for x? Good. Subtract the 1. So they're saying x equals 1,295. Is this true? Is this a solution? Let's check. Lucky for us, we can just do 1,295 store for x. And then we can put in the left side. Remember, when you guys put in this fraction exponent, that fraction has to be in parentheses, right? Okay, so check that for me.
48. Not negative.
You got positive 48, not negative 48? All right, so then is this a solution? No. All right, good. And you know, I keep writing no and yes, but if you want to write out extraneous, that's great. All right? Questions? You guys are doing a great job. Let's look at this one. This one's a really good one for us to see. So I see a radical. I want to get this guy all by itself. What do I need to do? Add what? Good. Add the x.
Frustration. That's wrong.
Frustration.
Like, that's how the real world works, though.
It is. All right, so then we have square root of x plus 2 equals x. Now, guys, how do I get rid of the square root?
Three squares.
Square it. Good. And whatever you do to one side, you do to the other side. Now the square root and that square go away. And then we have x plus 2 equals, on that side is what? Squared. Oh my goodness. I see an x squared, I see an x, and I see a constant. What do those three things make up? That thing, that's what? It is, okay, GCF, and then what? What's the specific thing for the 3? AM. Trinomial. Good, good. So if I want to solve using factoring, I need to make this whole thing equal to what?
0.
0. Oh my goodness, thank you guys. So you want to keep your square term positive. That means I want to move this guy. And I want to move this positive 2, so I'm going to subtract 2 as well. Great job. So like you said, this is solving by factoring, and it's using AM. AM. Well then, let's see. 2 numbers that multiply to give me negative 2 and add to give me negative 1. What are they? Negative 2 and 1. Good. Well, 2, since 2 is a prime number, you know, that was pretty nice, right? You can only have 2 and 1, right? So if you needed to, you could put the other combination in, but then you can add and see that that other one gives you a positive one, right? So we want this. So 0 equals, and guys, since this is just a plain exponent, squared, I'm going to use my shortcut here. Double parentheses, x, what 2?
And then minus 2.
Minus 2, and then x what? 1. Plus the 1, because that was a positive 1, right? I need to solve for both of those x's, though. How do I do that? What's my next step here?
Combine. Oh, no.
Equal them separately to 0. So our mini equations, right? So I have x minus 2 equals 0. And x plus 1 equals 0. Okay? And then if I solve for each of those x's, that's how I get my 2 answers, right? So x equals 2, and x equals, good. You know what that means? I got to check each of those separately. All right. So let's check, you know what? Let's check 2 and let's check negative 1. How about this half of the room checks 2 and that half of the room checks negative 1? Yeah? Share the responsibilities here. All right. 2, we said yes, this one works. But negative 1, when you plugged it in, you got 2. So no, it doesn't work because we should get 0, right? Good. So when you get this type of situation where you have an x squared, you have to solve by factoring. And you may get 2 solutions. One might work, the other one may. Both of them may work, or both of them may not work. Okay? So it could be any combination. All right? Okay, so let's look at this one. All right? So this one, a little bit different. I mean, it's still like the same thing. A little bit different. So I have a rational exponent here. Have to get that all by itself. It already is, right? So I'm going to change this to a radical form. It's power over root. Draw my root. Put 5 minus x. My power is 1. My root is 2. Do I have to write a 2 here?
No.
No. It's a given, right? It's known. So equals x plus 1. Yeah? Okay, so all I did was rewrite it. Now, how do I get rid of this square root? Take it to the power. Power of what? 2. So this whole thing is squared. The other one does too. But you know what? Since you have an x plus 1, you can't separate it, right? You have to make sure you put parentheses in the square, okay? Because they are 1 unit. All right, so then those 2 cancel out, and then we have 5 minus x equals, you know, be careful here, guys. X plus 1 squared is not x squared plus 1. You cannot distribute that exponent. This really means you have x plus 1 times x plus 1. Okay?
Can you combine them, though?
Well, you have to multiply it. How do you multiply when you have those 2 parentheses?
2x plus 2.
No.
Here's an x squared plus 2.
You have to double distribute or FOIL. Right? So, let's double distribute. That x goes to everything over there. What's x times x?
X squared.
X squared. What's x times 1? 1x. Okay, let's distribute this 1 now. That's the double distribute part, right? What's x? Well, what's 1 times x? Again, 1x. What's 1 times 1? No.
X squared.
1 times 1 is just 1, right? And that's the thing, that always gets the students. So look at that. On this right side, you have these 2 like terms here. You can combine. So we have x squared, yep, plus 2x plus 1 that equals 5 minus x. I have a trinomial situation again, guys. We need to make this equal to 0. Subtract that 5 out of there. And what do you do with this minus x? So then you have 0 equals x squared plus 3x minus 4.
You have to do AM.
Absolutely. AM. So, two numbers that multiply to give me negative 4, but adds to give me a positive 3. What are they? 4 and negative 1. Yep. Because 4 times negative 1 gives me negative 4. 4 plus a negative 1 gives me a positive 3.
So it'll turn into like that 4 thing and split it up and then
Yeah, you could do that. But that's what I'm saying. If you have just a plain x squared, you don't have to do the 4 thing to split. You can do the shortcut. Only when you have a plain x squared. Okay? But if you like the 4 thing, you can do that. Alright? Do you want me to show you the 4-way here?
I already know it. That's the way.
You're good? Okay. So I'm going to use the shortcut here because it's just a plain old x squared. So x and x. What goes in one of them? Okay, what 4? Plus or minus?
Plus.
Good. Plus 4, and then what with the 1? Good. Alright, and there we go, mini equations. So x plus 4 equals 0. X minus 1 equals 0. I expect everyone to be writing this down. This is the hardest type of problem you're going to get. X equals negative 4. And x equals 1. Okay, let's check. Here's the thing, guys, when you go to check this looks a little bit different. Go look at your original problem, right? Your original problem has on the left side 5 minus x to the 1/2 power equals x plus 1. So when you go to check 1, right? You got to put it in the left-hand side. What did you get when you put this in the left-hand side? Huh? You got 2? And then you have an x on the right-hand side too. So you got to put it in the right-hand side too and see if they equal each other. You know what I mean? Because this wasn't just a something equals 0. It was a something equals something else. You got to make sure those somethings equal each other. Does that make sense? So then this one, 2 equals 2. So 1 works. Make sense? You sure?
So you put it in separately.
Yes. So when you do x equals negative 4, let's see. When you check negative 4, store it for x, right? You got to put negative 4, you got to put the left side in.
Place x with negative 4.
Well, so put in the left-hand side. Put in, let's put that. So I'm going to put negative 4, store it for x. Put parentheses 5 minus x to the 1/2 power. Right? I got 3. Yeah? Okay, so now I'm going to check the other side. The other side of my problem says x plus 1, right? X plus 1. Since I'm using the same negative 4, what do I get? Negative 3. Well then, does 3 equal negative 3? No. So 1 works, but -4 does not work. Okay? Does that make sense? You had to check both sides because you had an x in both sides. Yeah? Questions? Okay, so the